Hello and welcome to the second part of the Breath of the Wild climbing system. In the last video we created where we can climb up, down, left and right with these animations. We can also exit climbing mode and enter climbing mode with this trace and prompt widget. In today's video we're going to create where we can climb to the top of a wall. So finished, it's going to look like this, where we're climbing. When we get to the top of a surface, we go to the top. Now as you can see, this project is already completely finished with all the features, so if you want to get it early you can get that on my Patreon, $5 a month, and you get all my project files, or you can get it as a one-time purchase. But of course in this video I'm going to show you how to do it step by step, so if you want to follow we'll find out and we'll do it right now. Okay, back into our project now. If you haven't done the first part, you should definitely do that first. I'll put a link in the description to the previous video. But now the first thing we're going to do is we want to have another trace check when we're climbing, which will check roughly around our head height if we have reached the top of the wall or not. Our whole system is really going to be based off traces. We're going to have a bunch going in different directions, and right now we're climbing, and we want to have a trace around where our head is going right forward into the wall, and as soon as that trace will no longer detect anything, so around here, right, our head no longer detects anything, we want to now say, okay, no longer detecting anything on the head trace, do something. And that do something is going to be climb on top of the wall instead of just climbing into the top. So last time we had our event tick and we had a can climb trace and store, all this stuff to check if we can climb. Now when we know we're already climbing, we're going to have another event, so we're going to create another new function and we're going to call it trace for top of wall. Alright, create that function, doesn't need any inputs, and we're going to fire this function, so go back to the event graph only when I guess this is already finished, right? We're not going to tag this right on the end. We're going to do on a separate second branch, and the way we're going to do it is we're going to pull everything over here to make a bit more space, and we're going to add a sequence node. A sequence node basically allows you to just organize things a little bit better, and I'll show you exactly how it works if you never used it before. So highlight all of this, we're going to drag it over here a little bit, disconnect the pin. If you press Alt and then click on a pin, if I just drag this back, if you press Alt and then click here, it gets rid of it. I'm going to search for sequence node, and off the first pin we're going to plug that into here. So every time we have an event tick, the first thing we're going to do is this event, and then after this branch is completely fired, whether it's true or false on here, it doesn't matter, we're going to come to this second pin, which is where we're going to do a check to see if we're climbing, if we're in climbing mode. Because if we're not climbing, there's no need to do this trace, but if we are climbing, and we know that because we can get the, where is it? I'm looking for the climbing movement state. Yes. So if climbing state equal enum, whoops, equal enum climbing, then we are going to say trace for top of the wall. We're gonna have a bunch of traces on the end. In the completed project files, I've got like 7 functions going on this true pin, checking it for left climbing, as in like turn a left corner, turn a right corner. We're gonna check if we're climbing down, if we have to orient our angle to the surface. There's gonna be a bunch of traces here, but for now we've just got trace to the top of the wall. So we're gonna go into this function, and we're going to say sphere trace by channel. Sphere trace by channel. We could do a line trace technically, and that would be like a line at the top of our character's eye level. But the problem with that is I found, because it's just a very, very thin dot, it's a lot more error prone, and there's a lot more like individual cases where, imagine you're climbing a wall. Well, I'll just try and like make one here. So we've got this wall here, and then imagine there's a teeny tiny gap in the middle right here. As you can see, you know, if we just had one trace at our eye level, we'd get to a point where yes, technically we wouldn't be hitting the wall, but we can see that the wall has such a small gap in it that we don't want to say climb to the top of the wall. That wouldn't make sense. So we just want to skip over that and keep climbing. So we do a sphere trace to have a little bit of a larger radius to the trace, so that we can bypass these edge cases where there's only a very small wall detection. With that in mind, we're going to go back to our function for sphere trace by channel, set the radius to 10. We can say draw debug type. We're going to put in our trace channel, not our trace channel, whoops, our draw debug type. We're going to put that for all of our traces so we can easily check whether to do them or not. Actors to ignore, we're going to say make, because it's an array, so we can't just plug in self. We have to make the array first. The first pin, we're just going to search for self, as in get a reference to self, so we're not, you know, tracing our self. And then for the start and end location, well, we want it to be like at our player, like on their eye line. So first we need to get the actor's location, because, you know, how are we going to find where they are if we don't know that it's a location? And we're going to add a little bit of height to their, you know, position. So we're going to say add, and it's going to add a vector for us, and we're going to add 75 on the Z axis. The Z axis is going upwards, so it's like height, adds a bit of height to them. When you say get actor location, it automatically starts roughly in the middle of the character. So when you add 75, I found from testing, this roughly gives around like height level, or where you'd have the hands climbing. We're going to plug this into the start pin, and then off of this vector, once it's had the 75 on the Z added, we're going to say add, and then we're going to say get actor forward vector down here, because we want to make sure this line is not just at the head height, but a little bit in front of the actor as well. Get actor forward vector, we're going to multiply it first, and then the result of this multiplication is going to be plugged into here, and the result of this addition is going to be plugged into here, right? So it looks like this. However, we need to do a little function to, you know, check how far we want to check how much forward it is. And the reason for that is because if we're climbing an angled wall, then we might have to change the angle at which we're checking, or the distance with which we're checking that we can still climb. So for example, if we're climbing a wall, and I'll just drag this one a little bit closer. So if we're climbing a wall, right, kind of like the example before, as you can see here, we, you know, we're not kind of on the wall, but we're still very close to the second one. So instead of climbing on top of the wall, we want to adjust to this next wall. Now in a future episode, we'll look at how we can adjust our character to the angle of the wall and keep sure they're close to the wall. So in this episode, we will look a little bit janky, but we'll address that later. But as you can see, we don't want us to stand on this little edge, or maybe if I make it smart, it's a bit more clear. We don't want to stand on this little edge. We want to carry on climbing on the wall on top, and that's why we check in front of the actor as well, not just at their head height. But also, if everything's angled, so if I select both of these and rotate them, not that steep, because we will want to be able to climb on an angle as well. So now if I'm climbing here, you know, it's quite a far way in front of us, but we want to angle our player, and we want to adjust how far we're trace checking in front of our player to make sure we stay on the wall. And that's why we're going to add another little function to check that. So we're going to add another function. We're going to call it increase distance based on wall angle. Increase distance based on wall angle. The first thing I want to do is cast this to a, well, not cast, but change it to a pure function. So just check the pure box right here. In the last episode, we talked about how that makes it one of the green functions, which doesn't have an execution pin. We will have an output though, and we will have an input. So to make this function as modular and reusable as possible, we're going to take the distance as an input. And I guess the distance, which is a float value, is just going to be how far in front of us do we want to check for the wall. Now, I suppose this is a bit of a preference value. It's how you want your system to feel. You know, do you want your angle to still climb up walls when it's really far away? or do you want to have a lot shorter of a distance where it makes your character jump on top of the wall? And I think I've always found 50 is quite good, but obviously that's personal preference, but that's what this distance is used for. This checks how far in front of the player we want to check if the wall is still. So we're going to do a line trace by channel. Line trace by channel. A line trace is fine here. We don't need a sphere trace. You could if you wanted to, I guess, but it doesn't really make much of a difference. We're going to say get actor location, because now we're checking, I guess, how far are we trying to find the wall, really. Get actor location, plug that into the start. We're going to say add. We're going to add 50 on the Z to go a bit higher, and then we're going to add this again, and this is going to go into the end vector, and we're going to plug in the actor forward vector by saying get actor forward vector multiplied, and we're going to multiply it by 200. And this way we can just find the wall that's in front of us. We're already climbing. We know we're climbing because we only run this on the climbing pin. Plug it into the second add there, not the first one. Goes into the second one. We know we're climbing because in the event graph we only run this when we're climbing. So we know we're climbing. We're checking for the top of the wall. And if we go 200 units in front of the player, we're just being absolutely certain, is there a wall or not? Visibility, actors to ignore, we'll say make array, we'll put this to self. We don't need to check for the draw debug type because I mean, you can if you want, but I only like to check the debug types that are essentially the main debug types. This is like a debug trace off another debug trace, and if we make everything visible, we're going to have a million lines going around and it's going to be super crazy at the end. So off here, first of all, we want to do a branch to check if we've hit something or not. Well, actually, we're not just going to plug in this return value because we want to check what we've hit first. We're not just going to say have we hit something, we need to check what we've hit. So we're going to get the impact normal. I'm going to do dot product. We looked at dot product in the last episode. I explained it in quite a lot of detail. Essentially, it checks how similar two vectors are. If they're going in the same direction, you get a 1. If they're going in opposite directions at a 90-degree angle, like a right angle, you'll get 0. And if they're going in opposite directions, you'll get -1. We did go into a lot of that in the last episode, so if you need a refresher, you might want to go watch that again just to see how we did that. We're going to search for acos degrees to convert this dot product value from 1 to -1 into a degree value, and we're going to do a branch. Not a branch, we've already got the branch. We're going to do less than, and we're going to put in 90. And this boolean value is going to be plugged into the branch. So we're checking if the impact normal, which is a vector that is at a 90-degree angle to the wall we've just hit, if that with a dot product against the up vector of the world is less than 90 degrees, then continue this. So what that actually means is if we're climbing a wall, I'll just compile, say this temporarily, go back here. If we're climbing a wall here, this wall is 90 degrees high. That little bug, that'll be fixed in a later episode because we'll do another episode for adjusting to the surface, so that's not really a bug. It's fine for now. As I was saying, we're climbing this wall right now, and this is a 90-degree wall. So basically what this calculation does is it does all this. It's 90 degrees, so false, blah, blah, blah. Everything's cool. But if we're climbing a surface that isn't 90 degrees, like this, then the true will fire, the false will fire, it's the other way around. So if it's greater than 90 degrees, so if it's 90 degrees or more, so if it's like straight upwards or pointing backwards at you, then we don't need to add any distance to the eye level check to see if we're still climbing the wall. But if the wall is less than 90 degrees, so it's at a slanted angle like this, then we need to add some more distance to the eye level trace to check that we're still climbing on the wall. So it's for these situations where we're climbing on this wall that we've done this little check, because now we're going to add some distance to whatever value is inputted here. This value that's going to be inputted, we're not choosing it in the function, we're going to choose it outside the function, so we can reuse it at a later point, and you can use it multiple times. So that's why we're not hard coding in 50 here. I will choose it for 50, but we're going to input it as a variable because I might want to use it again later and make it 100 for a different purpose. Off the true, we're going to say return node. We're going to add an output. It's going to be a float, and we're going to call it new distance. New distance. Okay. We're going to get this value from the acosd, from the acos degrees. Actually, first we should say minus, because this is going to go in the bottom. So subtract, put this in the bottom pin, put the first one in 90. So 90 subtracted by, and then we're going to multiply this as a float value. Now, some of these values, they are kind of just what I found from testing. Obviously, because I already done this project, I know what values work well. So I can't really say why I'm using these exact numbers. It's sort of just, I know they work because I've tested them. You could maybe say, I don't know, 80 and 4 and see if you like it. But I have found that these are the best numbers to make sure you're adjusting to the wall properly. So I guess you're just gonna have to take my word for it unless you want to experiment yourself. Instead of just dragging this distance pin and plugging it in over here, we can just search distance. And if we scroll all the way to the bottom, we'll find this function. If you have an input to a function, you can search that input as if it's a variable you've created. And you know it's an input because you can see this F with a little arrow pointing into it. And we can return that as the true value. And then if it's false, we need another return node, because we want to return another value, and we're going to get the acosd again. Just close that at the bottom, just had a little icon pop up there. We're going to get this acosd again. We're going to say subtract, and this time it's this subtracted by 90, because this time it's greater than 90 degrees. So this is, I guess, if the angle's a straight wall, or if it's pointing back at us, like we're climbing on a roof or something, or like the inside roof, the inside ceiling of a cave maybe. And then the result of this is going to be multiplied by 5, and then we're going to add this to distance. I'm just going to press Ctrl D on this variable to plug that into there. This is the distance we inputted. Put that into the new distance, compile, save, and now if we go back to our trace for top of wall function, we can drag in this increase based on wall angle, plug that into that multiplication pin, put this distance to 50, and now we have our wall trace. So if we go and climb, you can see when we're climbing at our head height, we're going into the wall. But when we go over here on this angled, as you can see, it extends, so it's actually going quite far in front of us. Our person isn't at the right position, I guess. It looks like it's too far below, and that's just because of our animations. So the animations we imported last time, I had to manually adjust them. That is not at all a problem with the system. It's just purely the animations. You could adjust the animations as in like literally make them lower on the character. In fact, on the finished system, they're all aligned properly, but because this is, I guess, the second time, and if you get the system, you don't get the one I'm making here, you get the one I made on the other one, because it's fully finished, commented, properly polished. I guess that, it's not really a problem. That's my point. And here, okay, so here we're not tracing anything. We're climbing here, and we're hitting something because the trace has gone green, but we climb here and it's all gone red because we're not hitting anything. And this, as soon as this goes red, we know to climb to the top, or at least rather to check if we can climb to the top, because what happens if we try and climb to the top and there's a little gap here, But imagine, let's say 30 centimeters above, there's another wall. So before we climb to the top, we are going to do another check. The check I want to do is basically find that position, find the top of the wall where we would be if we did climb to the top. Like here, we want to find the position. As you can see, the line's a lot smaller because of our calculation. We want to find the position where we would be if we'd teleported on top of the wall. And when we get to that position, we want to do a capsule trace to check by, I think it's 72 by 50, to see if our whole capsule could fit in that position. Because our player, we're going to take the same dimensions of our player, and we're basically going to say, is there a gap of this dimension, which is the size of our player, in this spot? And if there isn't, sorry, if there is a gap, so if there are no traces there, so if we don't hit anything on the trace, then we can climb to the top. And that's what we're going to do now. So we're going to do a branch off here. A branch. This is in the trace for top of wall function, by the way. After this sphere trace, we're going to do a branch, plug in this return value. And like we said before, this time, this is going to run off the false, because we want to know if there isn't something on top of us, because then we know there is a gap, and we need to check, are we then able to move up or down? The next thing we're going to do is we're going to do a sphere trace by channel, and we're going to make this go from the end location of this trace downwards into the floor of the wall. And I think it's quite hard to visualize, so I'll go back into the map to sort of explain what's going to happen here. As we're climbing, we're going up and up, you can see this trace in front of our player going into the wall, and right now it's fine that true is going to fire and it's only on the false we do something, but now we get to the top of the wall, and as you can see, we're not hitting anything. And you can actually get, if the trace doesn't hit anything, you can find, just by like with one of the built-in functions, the end position of the trace. It's one of the break hit result pins, so we can get the very end of this red line, and then we can say go downwards by like a really high value to see if we can find a wall there, and obviously, or rather a floor. And here there is obviously a floor, so then we're going to find that floor, and wherever that floor hits, then we're going to do a capsule trace right in front of us to see if there's room. So here what it would be is basically in front of our player, a little bit above like where they are now, we do another capsule trace to check if there's space, and then if there is, we'd go to it. So to actually make that, we're going to break this out hit value, because as I said, we need the end of that initial trace to find, you know, where we've just checked into the wall. The trace end, we're going to plug it into the start, add a reroute node, clean things up a little bit, drag this to the front. For the end of this, we are going to get the get actor up vector, and we're going to multiply it by -200, because I wanted to say, you know, go downwards. So we can get the actor up vector, and we can just like, you know, minus it and put it as quite a high number. -200 will, you know, it's going into the floor. This get actor up vector always knows which direction is up for the actor. It's completely relative to the actor. You can say get up vector, which is the world's up vector, which is always up in the world, but the get actor up vector is always relative to the actor. It's a super cool function. And without the get actor up vector, get actor forward vector, get actor right vector, this system would, you know, crumble. So I love these functions. They're our best friend in this system. All these traces, all these, you know, getting directions and working with vectors, it's a massive help. So we're going to add this result to the trace end. Just give it a reroute node, make it look a bit better, and then this is going to go into the end. We're going to give it a radius of 10 because it's, you know, better to work with radiuses, less chance of making a mistake. The debug type, we're going to plug in our draw debug type variable. Actors to ignore, we're going to make this a self. We're always going to say ignore self here, because if we're checking if we're climbing a surface, we always want to get rid of our own actor in the calculations. It might not make a difference, and in most cases it won't. So this is kind of just like an extreme case check, just to be extra sure. But why not? You know, if it's If it's easy and quick to do, why would you not do that extra check? After this sphere trace by channel, we're going to do a branch, and then on the true pin, we're going to do a capsule trace by channel. Capsule trace by channel. So we're doing this off the true pin because this means that we've got to a position on the wall where there's nothing, right? This is false, so we know there's nothing in front of us. Then we've gone to that position where our trace ended, we've gone downwards, and now we have found a floor. So we're checking, is there a floor on top of which we are able to stand? This might trigger false because maybe the wall you've climbed to the top of is really, really thin and is getting even thinner like the top of a mountain. And maybe it's just so thin at the top you can't stand on it because it doesn't like get hit by the radius. Just an example. Probably quite a rare situation, but we just want to check. So if there is something, if we're definitely able to stand on something because we've hit this trace, then we want to, I guess, define the positions for the trace, right? So I'm going to say get actor up vector, get actor up vector. We're going to multiply this by 80. Again, this is just another value. You might want to tweak it a little bit, 70, 90, but I found 80 works really good. We're going to add this to this trace end again. Okay, we're going to add it to this trace end, add another reroute node, so it looks all good. Another reroute node, and then they both go into the start and the end. Oh, sorry, this one line goes for the start and the end because we want to we're tracing for the capsule, which is around our player at one specific point. So, you know, we just want it in one point. We don't want it reaching out forwards into the wall. We want it simulating the capsule of our player. Here, this capsule, if we look at it, the capsule half height is 90 and the capsule radius is 35. This capsule is exactly what we want to check the size for. So we're going to go back here. We're going to say radius of 35 and we're going to say half height of 90. So now we're checking, you know, if there's room for us. Again, like always, we're going to put our draw debug type into the draw debug type pin, actors to ignore. We're going to say make and plug this pin as self. Cool. Then we're going to do a branch off of this return value, and true would mean that this capsule has hit something. And that is a bad thing because it means if we moved our character to the location on top of the wall, we would be hitting something, which is not what we want. So only on the false pin, we're going to do something. And that do something is going to be set actor location, which is just a node we can call set actor location. Now, I don't have any animations for this. I couldn't find any like free ones online. So if you had an animation pack, if you've paid like £20 or something for a bunch of climbing animations, or if you've made your own, then you might want to adjust this system so that you can have an animation to climb on top of the wall. But this is literally just going to teleport the character on top of the wall, which isn't great. I know you will want to change that if you put it into your final game. You'll want an animation for it, but it's extremely hard to find good climbing animations for free, so that's why I don't have any. But fundamentally, this is how it works. So I think if you understand how to do this, adding an animation is, in comparison, not that difficult. Now, we want to go all the way back here and get this out hit. We're not going to get this out hit because this is the capsule trace to check if we haven't hit anything, and this should be on false, by the way. I just realized I usually put it on true by instinct, but yeah, this is definitely false. This trace, so where we're trying to teleport to, we're going to get it, we're going to bring it over here, we're going to say break hit result, we're going to expand this out, we're going to get the impact point, and we're going to add it to something, and this is where we're going to move to. So the impact point is exactly where we've hit. Now obviously we don't want to move to exactly where we've hit because that's gonna put us into the floor, right? So we want to add a little bit of up vector to it, so our character's standing on it. We're gonna say get actor up vector. We're gonna multiply this, convert this to a float, just right click on it, convert it to a float, to 55. Before we plug that in though, we're gonna do a little bit of add. We're gonna add get actor forward vector multiplied by -10. So get actor forward vector. We're gonna multiply this by, this is gonna be converted to a float, by -10. And we're going to plug that into here, and then this add gets plugged into here. You might wonder why we've added this get actor forward vector, and it's because back here somewhere, when we trace for the line, we're adding like a little bit in front of our character. If I go back and I climb the wall, as you'll see, if we teleported just to there, we might be a bit far in front. I mean, this really is preference. I might actually get rid of this. Okay, that's fine. That's not finished yet. Don't worry. That's not the final. That's not the final system. Okay, that did not at all show what I wanted. It's because it's not finished. We need to finish the logic first. And then we need to say exit climbing mode basically at the end. So we had a function for this. Let's just check what it was called. Leave climb mode. Go back to here, leave climb mode. So I guess this is just to make sure you don't go too far into the wall. I like it at -10 because in my other system I played with the value a little bit and I liked it at -10. If you don't want it at -10, you could say -20, or you could have it at 0. But I guess -10 for me just works quite nice. So now we're climbing, and boom, we just got to the top of the wall. So yeah, as you can see, we start climbing and we're doing a check in front of our player to see if there's anything there. And then as soon as we get to the top, and as soon as there's nothing there, we're going to do a trace in front of the player. Then we're going to do a trace down to find the floor. If you look at the character's feet, exactly where the character's standing now, the foot that's on the floor, we do a trace at that position to check, is there something there? If there is something there, we do a capsule trace, which is basically, again, what the trace around our player is, just a little bit taller and thinner, to see if there's room for our character, and if there is, we transport our player there. That's great. So yeah, that's today's episode finished. I'm not sure exactly what I want to do next time. It might be how to climb down. It might be turning corners. I'm not sure if obviously we'll do everything at some point, but I'll just have to think about what's the best thing to do next. But yeah, like I said, if you want to get the complete project, it's on my Patreon, and then you won't have to wait for the following videos to come out. But yeah, if you want to see the next video, make sure to subscribe, and then you won't miss it. Obviously, you get notified. Leave a comment, let me know if you like the video or not. It helps with the algorithm. Other than that, thanks for watching.